This is problem 32 from chapter 9. So if you go to the book, you'll look at problem 32, you'll see something very similar to this. Bias back in 1991 studied mean numbers of auto dealers. We're going to define mu as the mean number of dealers visited by all late replacement buyers. In other words, mu is our population mean. Population mean. We don't know mu, but we're trying to estimate mu based on the sample mean. Let's go over here into Excel and put some of these numbers. So x bar, the sample mean is 4.32. S, the sample standard deviation is 0.67. And n, the sample size, is 100. Random sample of 100, x bar is 4.32, s is 0.67. We hypothesize that mu is 4. And how do we know that? Because if we look here, we're supposed to set up the null and alternative hypothesis needed if we wish to attempt to provide evidence that mu differs from 4 dealers. So mu naught is going to be 4. That's our hypothesized value. Our null hypothesis only can be one of 2 possibilities. In this case, not equal to or equal to. Now, if you remember from the book, the null hypothesis can only be one of 3 options: equal to, less than or equal to, or greater than or equal to. Your null hypothesis must be one of those 3, which means the equal to is the correct answer here. The alternative, if you remember from the book, has to be either greater than, less than, or not equal to. And here, not equal to is the only option, so that's got to be what it is. Now we calculate our test statistic. Remember from the book the formula for the test statistic. That's going to be, it's a fraction. In the numerator, it's going to be what we observe minus what we hypothesize. In the denominator, it's going to be s divided by the square root of n. So our test statistic is 4.776199. We're supposed to round to 3 decimal places, so that's 4.776. Again, let's take a look at the test statistic formula. It's what we observe minus what we hypothesize in the numerator. In the denominator, it's going to be s over square root of n. The next part is we need to calculate critical values. Critical values corresponding to an alpha of 0.05, an alpha of 0.025, an alpha of 0.005, and an alpha of 0.0005. We're going to use Excel to do that. It's t.inv. It's going to be equal t.inv, and the probability for the first one is 0.05. Notice we also have to specify degrees of freedom. Degrees of freedom are always for a one sample case, such as this. We're only looking at one population. We're not looking at the relationship between populations. We're just looking at one population, so it's termed a one sample case. In the one sample case, degrees of freedom are always going to be the sample size minus 1. N is 100. 100 minus 1 is 99. Notice that the t.inv gives us a negative number. We're going to ignore that negative number and just call it positive. Okay, so what would be the critical value corresponding to 0.025? $1,984. 0.005. 2626. 0.0005. 3.392. Now, where did these values come from? Well, notice that we're setting alpha equal to 0.1, 0.05, 0.01, and 0.001. So these are the alpha over 2 values. So instead of calculating these with t.inv, we could have calculated them with t.inv.rt. I'm sorry, .2t. That gives us the two-tailed critical value. Here, the probability is going to be the alpha value, still 99 degrees of freedom. And notice it automatically gives us the positive. So this next one, where alpha is 0.05, and this one for an alpha of 0.01, oops, did that for only 9 degrees of freedom. And then for an alpha of 0.001, and we'll get the same values. But that's where these odd numbers came from. Came from alpha over 2 for the 4 usual alpha values that we have. So our observed statistic is 4.776. It is more extreme than all of these critical values. Therefore, it's in the rejection region for all of the critical values, which means that there is extremely strong evidence that mu is actually greater than. Why greater than? Because our test statistic is positive. That tells me greater than. Or because our sample mean is greater than 4. This part tells me that the population mean is not 4. Our sample mean is greater than 4, therefore I can conclude that the population mean is greater than 4. Still don't know what the population mean is, but I do have I have extremely strong evidence that it's greater than 4. That's the first one I wanted to go through. I also want to look at the one that deals with the two types of error rates. There we go. 9.3. So we're going to recall our very satisfied customers, etc. Wishes to use 65 to provide evidence supporting the claim that the mean exceeds 42. In other words, mu is greater than 42. Well, we know that mu greater than 42 has to be the alternative, because the alternative hypothesis always has one of the following: less than, greater than, or not equal to. Since the alternative is greater than 42, the null has to be the logical opposite of greater than, which is either not greater than or less than or equal to. They mean the same thing. Now, in the context, making a type 1 error, always a type 1 error is rejecting a true null hypothesis. That is, concluding that mu is greater than 42, except that it's actually less than or equal to 42. A type 1 error is always rejecting a true null hypothesis. So we're going to say that a type 1 error here is that mu is greater than 42, because we just rejected the null hypothesis, when mu is actually less than or equal to 42. We reject the null hypothesis and decide for the alternative, even though the null hypothesis is correct. Type 2 error is the other way around. Type 2 error is we fail to reject a false null hypothesis. We fail to reject a false null hypothesis. In other words, we conclude that H0 is true when in all reality HA, the alternative hypothesis, is true. So we decide that the null hypothesis is true even though it's not. Type 1 and type 2 error come from what we decide about the null hypothesis and the alternative hypothesis in relation to reality. In a type 1, we conclude that the alternative hypothesis is true and it's wrong. In a type 2 error, we decide the null hypothesis is correct and it's wrong. I'd put that on note cards and memorize it. Type 1, conclude the alternative, but it's not the alternative. Type 2, conclude the null, but it's not the null. And that's it. Hopefully this was a little bit helpful. Take care.